Hello everyone, my name is Andrew. Today we'll continue learning Python, and today we'll talk about memory management in Python. So let's start. Once again, today we'll talk about memory management and what is the difference between Python and other languages. So in Python, every variable is a link or a pointer, whatever you like to call it, because Python uses C underneath it. So Python does not just work with our computer directly. It's an interpreted language that uses C underneath. And C language has a lot of pointers and a lot of that stuff. So pointer is basically not a variable that equals something. So if I write a equals 1, I do not say that a is 1. What I'm saying is actually a points to a memory section where there is one where there is one. So a points to the memory section. A is not 1. It points to the memory section, and the same goes with every variable. So if I say string, a points to string. If I say that my a is equal to, I don't know, to anything, to a list, a is going to point to a list, but a is not the list itself. That's very important. And pointers bring a lot of good things and a lot of bad things in Python. So how memory management works? Memory management basically counts all of the links to your object, and if there is none, we delete that object. So right now we only have one link to that object 1. So there is one link here from variable a. If I'm gonna say variable a equals to something else, so let me actually give you an example with 1, 2, 3, because lists are immutable and we can delete like integers, because if I delete 1, then what will I do if I just say b equals 1? So integer, there's like a little bit of a difference between integers and more complex types. So I'm going to use a complex type, which is relatively complex type, which is a list. So we have a list. And what if I say a equals to 4, 5, 6? Basically what we're doing here is we had the list 1 to 3. And when I'm saying a equals 4, 5, 6, I do not change the value inside of 1 to 3. What I'm doing is creating a new list and changing the link. Just like that. So now 4, 5, 6 object has one link on it, but 1 to 3 object has 0. And Python garbage collector needs a special thing that allows us to delete our objects, because we can't manage our memory ourselves. So there is no Python memory management in our code. We can't do it. And the only thing that we can do is either remove all of the pointers to our object, as I did here. So remove all the pointers. A pointed to 1 to 3 and we changed it to 4, 5, 6. Or we can remove all of the pointers, and that's the only way our object is going to be deleted. So if we don't have any pointers on our object, it's going to be deleted by the garbage collector, not by us. And that's the basic idea. If I'm going to have two links, two pointers, two variables on my 4, 5, 6, because I can do that. If I'm writing a equals 4, 5, 6 and then I'm saying b equals a, that does not mean that b is a new object that copied the value of a. What that means is a equals b or b equals a, is that both of those objects point to the same memory, to the same memory. So basically to the same object, 4, 5, 6, and that's very important because it can bring a lot of bugs in your code. So one of the most popular bugs is if I change a, so a from a on the index 0 is 10, then my b is also gonna change. So let's print b, and you will see that b is 10, 5, 6, but it's supposed to be 4, 5, 6. And that happens because both a and b point to the same object. And that's how basically memory works. If there is no pointers to our object, we delete the value in the memory. If there are pointers, what does that mean? Is that we are using our object and we need to somehow preserve it in order to do something with it in the future in our code. And there are some interesting ideas that derive from that. So the first one is import sys. It's a library, and we have a function called sys.getRefCount. So getRefCount is a function that basically allows you to get the value of all of the links. Not the value, but how many links do we have. So reference count. And we can provide an object here, so a, and let's run our program. We can see 3, but there are only 2 objects that point to that variable. That happens because getRefCount is a function, and we add an argument inside of that function. And because of that, argument is another link that uses our 456 object. So when I'm using sysgetRefCount, I'm basically saying that we have some argument, let's call it, I don't know, let's call that argument, I don't know, C or arg. That is the argument inside of the function, and it points to the 456 as well, because we provide that variable inside of the function. So what we can do in order to get the real link count is just subtract 1. So let's run, and as you can see, 2. So now we have two links, A and B. We remove that arg, and we already see the real links to our object. So that is the first thing that you should know. Yeah, sysgetRefCount, just get the count of your, so how many references are on your object. And the next idea is pretty important because it's called delete. So del, delete, whatever you like. Some people think that delete just deletes the variable. However, in Python, delete does not do anything because, as I said, we can't manage the memory ourselves. I can't just say delete that or delete that. So the only thing that we can do is change the objects, change their state, and create them. But I cannot delete them manually. And because of that, delete is not an operation that deletes your object. It's the operation that removes a link from your object. So if I'm saying delete A, I'm not going to touch my object because it has B as a pointer to that 456. What I'm going to do is I'm going to just delete my A and delete the link from that A. And now we only have one link to our 456. So what you can do is have two links on your object, delete one link, and still preserve your object. Let me just show it to you. Print B, 1056. And B and A point to the same object, but if we write delete A, the object is not deleted. Only the link is detached from that memory slice. That's how it works. And if I delete both of those links, then of course I cannot use the object. And if I don't have any links, Python garbage collector will come and delete it. Python garbage collector, once again, is just a process that deletes all of your objects that do not have any links on them. So in our case, if I delete B, I do not have any links to my 456 object, and we should delete it because we can't use it. So what does that mean is that if I don't have any links, I do not know where that object is located. So because B and A were the links that pointed to the memory slice, to the memory fragment of that object. If I delete both B and A or all of the links from my object, then I do not know where that 456 is located. And because of that, I cannot use that object in my code. So that does not mean that, I still can use it with some manipulations, and it's going to take us to C programming language, to C Python, but it's not what we want. Because 456, if it does not have any links or any object, if there is none links to it, it's going to be deleted. And that's basically the idea of Python memory management. So remember about sysgetRefCount in order to get the value of, or the count of links on your object, and remember about delete. It does not delete your variable, but rather removes the link. So thank you for watching. My name is Andrey. Subscribe to my channel, leave a like, leave a comment, and bye bye.